We want to see how, if we know one angle, how we can solve any angle in parallel lines with a transversal. Transversal, I believe, was Greek, relating to the word cutting. It's the line that's cutting through. The way we can understand each of these angles and not have to memorize even the names. There's a separate video I did on the names. Are they same side of the transversal, or are they alternating, one on each side? Like these are alternate, one on each side of the transversal line. And then are they interior or exterior? The interior is in between the parallel lines. So these would be called alternate interior. So that's a different video. We're going to look at how to solve. So the two main things we want to look at are, in addition to corresponding angles, are vertical angles and linear pairs. Those are essential to understanding, and then we can solve any one of these problems. The first thing we want to refresh our memory about is what corresponding angles look like. Corresponding angles are matching angles. They're matching the same position but on a different line. So if we have lined paper, when we draw transversal, each angle in the same corner will be the same value. They match or they correspond. Okay, so one of the ways we can find those corresponding angles is, well, a few ways. Number one, when you're asking is it interior or exterior, you'll notice corresponding have one of each. Alright, a corresponding angle is really a translation. What you're doing is you're sliding the angle here up one line, and it will remain the same value. It'll be equal or congruent. So we know corresponding angles are congruent, which means we can set them equal when we are solving. Anything congruent means the shape and size are equal, so we can set them equal. The corresponding angles don't have to be on the top right. I'll give you an example of what I mean by top right. But if this is the bottom left, then the other corresponding angle that matches that position would be, if you slide down, it would be on the bottom left. One way to tell where we're looking, I like to draw a circle with the center at the vertex for two reasons. Number one, you could see the position. The green angle is in the bottom left, the other green angle is in the bottom left. Those are corresponding, they match. The other thing you can see is linear pairs. These two angles make a linear pair. These two angles make a linear pair, because a linear pair will cut a circle in half, my poorly drawn circles, and half a circle makes 180. So corresponding angles, I'll give one more example, might be the top left, this angle. So the same position would be top left here. So that's the first step, understanding what a corresponding angle looks like. So a corresponding angle has different variations. Whoops. And the next thing we need to know and understand, because we'll see them every time we have parallel lines in a transversal. The next one is vertical angles. Okay, vertical angles are also congruent, and everything that's congruent, we're going to set them equal to solve. So vertical angles are a reflection. They flip over when you have two straight lines. This angle here, if we flip it over, it would be here. They are called vertical angles. The word vertical hasn't to do with the lines, angles being up and down like the word vertical, but because they all meet at the vertex. So they're vertical angles because they have a common vertex and they are across from each other. Okay, another example might be here, and then we flip over, it would be there. Those are vertical angles. So if one is 100 degrees, the other one is 100 degrees. Vertical angles are always congruent. Corresponding angles also were always congruent. And all of the other solving could be based off of these two things and then what linear pairs are. So we also see linear pairs whenever we look at the parallel lines and the transversal. Okay, linear pairs are when you have a straight line, linear, and it's a pair of angles, so that when we fit the two angles together, when we draw a circle, it's really cutting off half of the circle, which is 180 degrees. So we begin to see that a plus b will have to equal 180 degrees. So there's going to be two choices as we learn to solve these. They'll either be equal, the same number, or they will be added together and added up to 180 like a linear pair. So let's take an example of a corresponding angle. This is 40, this is x. So x will equal 40 because we've already learned what corresponding angles are. If I were to change that or add, I'll add the letter y over here. Well, it'll actually be better to look at if we just draw a new problem. So again, these are going to be the three basic things, and then from here we're going to learn in a few minutes just how to solve any one of these types of problems. Okay, my steps that I do, I'm going to fill in the corresponding one of the one I know. And then I'm going to look to see if it ends up being vertical or a linear pair, if it's not just straight corresponding. So let's say I wanted to find these two angles. If I could take the one I know 110, and fill in the corresponding would be here, then I know it's 110. Now I can easily see if I flip it over to the vertical angle, then x equals 110. I could have done I can add another letter. I can add a y. So if we pretended that we didn't do anything, and I said, well, how would I solve this? Is it equal, or do I add them and set them to 180? Again, when I take my one value I know, 110, fill it in for the corresponding, 110. Now y plus 110 are a linear pair. So we know they add up to 180. So y will equal 70. So we'll do a few of the ones with numbers, and then we'll look at some with algebra. We're going to fill in the corresponding and then look to see if it makes a linear pair or if it is a vertical angle. Let's try another one. So I'm going to choose the one I understand is 70. You could choose either one. I just prefer to choose that one. It's on the bottom left, so I'm going to mark here 70 because it's corresponding. And now I can see the angles are vertical, so x must equal 70. I can try one here next to it. So this will work in any combination. So these are what we would call same side interior. The one we just did was alternate exterior. These are same side exterior, I'm sorry. They're on the exterior or outside of the parallel lines. So in order to solve them, I'm going to fill in the one I know here is 70, and here's the corresponding 70. Now I can see the linear pair. 70 and the x make a straight line when we combine their two angles. So when I combine this angle and I combine this angle, right, they make a straight line right here. So x is going to be 110. Well, what do we do when we have algebra? Be more than just one variable. And they're going to be the same idea. Okay, so here's x plus 5, and I'll put in 2x plus 55. So if you notice these angles, these are corresponding angles. So if I tried to match them, well, they're the same. So if they're the same, I can set them equal. If I want to, I could move one up and put it set equal, but I'll end up doing that over here anyway. Right, corresponding angles are equal, so things that are equal, we set them equal and solve. We get y alone, or get x or the variable alone. So I'll subtract, I'll subtract x on both sides, and then I'll subtract 55, and x will be negative 50. Now, that's not possible to actually have a negative angle, but I just made that problem up. Correct setup and correct solving. What if it looks like this? So these are called same side interior. Now we can choose one since neither of them are pure numbers, so I'll choose this one and I'll find the corresponding is there. So 2x plus 10 is the same right there and there. Now I hopefully can see that I have a straight line and then two angles. They are A and B, and those are a linear pair. So the two things are equal, or sum is equal to 180. So we'll take, just like we say A plus B, we'll take this whole thing, 2x plus 10, and add it to the other one, and set it to 180. Okay, because linear pairs are always equal to 180. So 5x plus 20 is 180. Subtract 20 on both sides. 5x is 160. Divide both sides by 5. And x will be 32. If you wanted to get the angle, we could plug that number in. So this is a method that will work and make it very easy to understand and not memorize. If you can fill in the corresponding and then check to see if there is a linear pair or vertical angle. Linear pairs like this one, we add and set to 180. They're supplementary. And if things are vertical, they're congruent. They're copies that are reflections of each other. They flip over. And so things that are congruent, we set them equal. Just like correspondings are equal, we can set them equal. Hopefully that helps you understand a little bit more.